Number one, a random variable x has the distribution, binomial distribution, 4,500,000 and 1 over 1 million. Use a Poisson distribution to calculate an estimate of probability x greater than or equal 4. Given that through this binomial distribution information that n equal 4,500,000, and then probability or p 1 over 1 million. Now we want to estimate probability x greater than or equal 4. Using Poisson approximation, lambda, we can determine through n multiplied by p, or n times probability. So it means 4,500,000 multiplied by 1 over 1 million. So it becomes 4.5. So we approximate x with the Poisson distribution lambda equal 4.5. Next, we will compute this one, probability x greater than or equal 4 using the complement rules. It is 1 minus probability x less than or equal 3. It means 1 minus probability x equal 0 plus the probability x equal 1 plus the probability x equal 2 and the probability x equal 3. And based on the Poisson formula, I'm writing here probability x equal k. It is e power minus lambda times lambda power k over k factorial. We are going to using this rule. So lambda is 4.5. So it means this probability becomes e power minus 4.5 times 4.5 to the power 0 over 0 factorial. Equal here. And after that, this one. Oh, I forgot to write in 1 minus. It to be 1 minus. Okay. Plus now this one. It means e power minus 4.5. 4.5 power 1 over 1 factorial. Now this one. E to the power minus 4.5 times lambda or times 4.5 squared over 2 factorials plus e power minus 4.5 times 4.5 cubed over 3 factorials. Scroll down first, okay? So it becomes, and if we calculate, the result is 1 minus. This fraction equal 0.0111. And this fraction, it equals 0.0500. And this fraction, it equals 0.1124. And this fraction is 0.1687. And if you calculate, the result is 0.6578. round off becomes 0.6583 significant figures. Number two, the length of a random sample of 50 rows in a certain region were measured using the result a 95% confidence interval for the mean length in meters. So it means this alpha, okay, 95%, of all rows in this region was found to be 245, 263. Find the mean length of the 50 rows in the sample. So it means we will find the sample mean, the sample mean. Sample mean equal 245, okay, this number, okay, plus 263, this number divided by 2. And the result is 254 meters. Okay. Next, B. Calculate an estimate of the standard deviations of the length of roads in this region. We will find the standard deviation. So the first step, I would like to find margin of error. The margin of error, or ME, 263 minus 245 divided by 2. And it is 18 divided by 2 equal 9. That is the margin of error. For a 90%, a 95%, or 95% confidence level, the critical value, or C score is C equal 1.96. So margin of error, the formula is C minus S divided by square root N. Or we can rearrange this formula if S is the subject, because we are going to find standard deviation. So S equal margin of error square root N times square root N over Z. So it becomes 9 because margin of error is 9 times square root 50 over, see this one, 1.96. And the result is 32.47 meters. It is 32.5 meters. C. It is now given that the length of roads in this region are normally distributed. State with a reason whether this fact would make any difference to your calculation in part B. I have provided my answer about this one. What is question? Next question. Number 3. A factory owner models the number of employees who use the factory canteen on any day by the distributions B25 and P. In the past, the value of P was 0.8. A new menu is introduced in the canteen, and the owner wants to test whether the value of P has increased. On a randomly chosen day, he notes that the number of employees who use the canteen is 23. Use the binomial distribution to carry out the test at the 10% significance level. 10%, it means 0.1. Right, so the first step, I would like to set the hypothesis. The null hypothesis is P equals 0.8, while the alternative hypothesis is P P greater than 0.8. Next, let X, which is the binomial distributions of 25, and based on this information, probability 0.8 under the null hypothesis. Right, now we observe X equal 23 based on this information. So the probability X greater than or equal 23 equal probability X equal 23 plus the probability X equal 24 plus the probability X equal 25. Recall that N equal 25 based on the information. Right. As we calculate for this probability, we can find through combination 25, 23, 0.8 power 23, 0.2 squared, 0.2 because 1 minus 0.8, 2 because 25 minus 23. I think you are familiar with this calculation, 25, 24, and then 0.8 times 24, and then 0.2 per 1. So that plus combination 25, 25, 0.8 power 25, and 0.2 power 0. If we compute, it's going to be 0.070835. Okay, this calculation equals 1, and this calculation equals 0.023618, and this calculation equal 0.0037779. And if you're computing, it's gonna be 0.0982247. Round off becomes 0.0982. And if you compare with alpha 10%, it is less than 0.1. If it's less than 0.1, it means we can state that there's evidence. I have provided my conclusion here. This one. Okay, I'm gonna put here. Okay, this is the conclusion, because if this number less than 0.1, B, given that there are 30 employees at the factory, comment on the suitability of the owner's model. So this is my answer about this, my comment about this question. Number 4. A population is normally distributed with mean 35 and standard deviation 8.1. A random sample of size 150 is chosen from this population, and the sample mean is denoted by X mean, like this, X bar. Find the probability mean greater than 36. Find standard deviations first. The standard deviations of mean. So the formula standard deviations of mean equals standard deviations over square root of n. And this information that standard deviation is 8.1. So 8.1 over square root of n is 140, this one. If you calculate, the result is 0.684574 round off 0.6846. After that, convert to the C score. We want to find the probability, this one, probability X mean greater than 36. So we calculate that the C score, C equal 36 minus 35 over 0.6846, this number. And if you compute, the result is 1.46076 ohm or 1.461. Now we find the probability Z greater than 1.461 equal 1 minus the probability C less than or equal 1.461. So it is 1 minus 0.9271, and the result 0.0729. So the probability mean greater than 36 is 0.0729. Next question. It is given that the probability mean less than A equals 0.986. Find the value of A. From the standard normal distribution table or calculator, we gain that probability Z less than Z equals 0.986. So this Z equal 2.21, Z table. Use the Z-score formula to find A, and the formula Z equal A minus mu of X times standard deviation of mean. This is mean. So we can rearrange the formula A. If A becomes the subject, Z times one standard deviation plus the mean. So it becomes Z equal this one, 2.21 times 0.6846 plus 35. And if you compute the result, 36.51. Next question. Number 5. A machine puts sweets into bags at random. The number of lemon and orange sweets in a bag have the independent distributions Poisson distribution 3.7 and Poisson distribution 2.6 respectively. A bag of sweets is chosen at random. Find the probability that the number of lemon sweets in the bag is more than 2, but not more than 5. So between 2 and 5. So based on this question, based on this statement, we are going to find the probability X, so X greater than 2, at X greater than 2, less than or equal 5. And it is probability X equal 3 plus the probability X equal 4 plus the probability X equal 5. So based on the Poisson probability mass function, we can determine the probability probability x equal 3, e power minus 3.7 times e times 3.7, 3.7 power 3 divided by 3 factorials plus e power minus 3.7 times 3.7 over 4 over 4 factorials plus e power minus 3.7 times 3.7 power 5 over 4 factorial, 5 factorials, I mean, and compute 0.2089. If you compute this part, this is the result. If you compute this part, this is the result, 0.1933. And if you compute this part, the result is 0.1428. And if you calculate all, the result is 0.545. Next question. Find the probability that the total number of lemon and orange sweets in the bag is less than 4. Let t equal x plus y. Okay. So t is the total number of sweets. The number of lemon sweets is x, okay, with the Poisson distribution 3.7. And the total number of orange sweets is y, with the Poisson distribution 2.6. So lambda equal 3.7 plus 2.6 equals 6.3. Let's find probability t less than 4. So t less than 4, it means probability t equals 0 plus probability t equal 1 plus the probability t equal 2 plus the probability t equal 3. Less than 4 means not include 4. Now, we are going to using the Poisson probability mass function. So this probability is e power minus 6.3 because lambda is 6.3 times 6.3 power 0 over 0 factorial plus e power minus 6.3 times 6.3 or 1 over 1 factorial plus e power minus 6.3 times 6.3 squared over 2 factorials plus e power minus 6.3 times 6.3 cube over 3 factorials. And if you compute this part, the result is 0.001832. If you compute this part, the result is 0.01159. If you compute this part, 0.0363. If you compute this part, is 0.0763. So total is 0.126. Next question. 10 bags of sweets are chosen at random. Use approximating distribution to find the probability that the total number of lemon sweets in the 10 bags is less than the total number of orange sweets in the 10 bags. Let L is the total number of lemon and O is the total number of orange in 10 bags. This is in 10 bags. This is in 10 bags also. Then the Poisson distribution becomes 110 times 3.7. It's going to be Poisson distribution 37. Okay, it's mean. And orange becomes the Poisson distribution 10 times 2.6 becomes Poisson 26. Since the means since the means are relatively large, we can use normal approximation. The normal approximation the symbol like this. I would like the symbol of this is normal approximation symbol. So it means lemon and orange normal approximation becomes okay for lemon the normal approximation 37 and orange the normal approximation comes 26 okay. Let D equal L minus O, lemon minus orange. Then using properties of normal distribution, it's going to be D, okay, mu D equal 37 minus 26, 11. And then 1, well, 37 plus 26, 63. So it's going to be D, the normal approximation, 11 and 63. After that, we are going to find the probability. Find the probability lemon less than orange. So it is the probability D less than orange. Less than, oh, sorry, it's going to be I brought to standardize first. Z, 0 minus 11 over square root 63. Okay, square root 63 is 12.94, and this is minus 11 minus 1.385. Now, using standard normal table, in the standard normal table, the probability Z less than minus 1.385 becomes 0.0834. So the probability, this probability L less than O, well, 0.083. This is the answer. Number 6. The time X hours taken by a large number of people to complete a challenge is modeled by the probability density function given by this function, where A and B are constants. State what the constants A and B represent in this context. I have provided my opinion, my answer with this question. 1. B, show that A equal B over B plus 1. We will use the fact that the total probability under a probability density function or under PDF must be equal 1. Okay, the total probability density function, total probability density functions equal 1. So I will using integral a to b of 1 over x squared. This is the function. And a to b because the interval from a to b. Okay. The x equal 1. So it means it is the integral. The integral of these expressions is 1 minus 1 over x. And after that, substitute b and a becomes minus 1 over b minus 1 or minus 1 over a, like that. And I will continue here. That's 1 over b plus 1 over a equal 1, according to this statement. And I would like to rearrange this equation becomes 1 over a equal 1 minus 1 plus 1 over b. After that becomes 1 over a equal b over b plus 1 over b. So 1 over a equal b plus 1 over b, like this. So it means a equal b over b plus 1. Proof. Next question. It is given that expectation x equal learn 3. Show that b equal to and find the value of a. The x equal learn 3, so it means I would like to using integral a to b of x f x because expectation ex dx. So it is integral fx is 1 over x, 1 over x squared, so it becomes x over x squared dx, like this. So it's going to be integral 1 over x dx. And integral of this 1 over x is ln x. Substitute b and a, it becomes ln b minus ln a, or it is ln b over a. According to this statement that ln b over a equal ln 3, it is. So it means it means b over a equal 3. So b over a equal 3, or a equal b over 3. Substitute substitute this information into the previous information that a equal the previous information that a equal b over b plus 1. We are going to substitute this information. So it's going to be b third equal b over b plus 1. And if we crossing multiplication, it becomes b squared plus b equal 3b, or b squared minus 2b equal 0. So b times b minus 2 equal 0. So b equal 0 or b minus 2 equal 0. So do not using this one. Do not. We're using this one. So it means b equal 2. If b equal to substitute into this equation, so a equal 2/3. So this is b and this is a. A equal 2/3 and b equal 2. Next question. Find the median of x. To find the median of a continuous random variable x, we need to solving the probability x less than or equal m equal 0.5. M is median. Okay, based on this statement. So we will find the integral to m 1 over x squared dx 0.5. One. We are going to calculate this one. We're going to find m. So it means the integral 2/3 m, and the integral of these expressions is minus 1 over x, like this. So it's going to be minus 1 over m minus 1 over 2/3, like this. Becomes minus 1 over m plus 3/2. So it becomes, so I'm going to write it here, 3/2 minus 1 over m. And based on this statement that the probability equals 0.5. Okay, let's calculate m. So m, 1 over m equal 3/2 minus 1/2. 1 over m equal 2/2 or 1. So m equal 1. Next question. Number 7. The height of 1-year-old trees of a certain variety are known to have mean 2.3 meters. A scientist believes that on average trees of this age and variety in her region are slightly taller than in other places. She plans to carry out a hypothesis test at the 2% significance level in order to test her belief. Set the probability that she will take a type 1 error. I have provided my answer for this one, for this question. She continue the next question, B. She takes a random sample of 100 such trees in her region and measures their height, h meters. Her results are summarized below. N equal 100, sigma h equal 238, sigma h squared equal 580. Carry out the test at the 2% significance level, or alpha. This is alpha 2%. Hypothesis first. The null hypothesis, mu equal 2.3. And the alternative hypothesis, mu greater than 2.3. And after that, we're going to find the sample mean and the sample variance. Mean first. Mean equals sigma h over n. Sigma h is 238 over 100. This one. And sample mean equal 2.38. And after that, the sample variance squared 1 over n times sigma, this is the formula, sigma of h squared minus sigma h squared divided by n. 1 over 100 times 581 minus uh, minus 238 squared so over 100. And if you calculate, the result is 0.1356. So standard deviation, we can state the standard deviation as the root of 0.1356, 0.3682. So this is the standard deviation. Okay. And next, the scientists, wait, I have to compute, wait, not yet to compute. I have to compute the test statistic, I forgot, the statistic. We are going to use in one sample z-test, okay, because n equal 100. Okay, this is the large n. So z equal sample mean minus mu s over root n 2.38 minus 2.3 over 0.3682 over square root 100, 0.08, yeah, correct. And if you compute this one, 0.03682, okay, 2.173. So I would like to state that at the 2% significance level for a one-tailed test, the critical value Z value is Z 0.02 equal 2.054. This is the critical Z value, the critical value. Okay, the critical value is this one, 2.054. And if you compare the 2.054 and Z, this one, okay, this is 2.173. So 2.173 greater than 2.054. So decision that Z equal 2.173 greater than C equal 2.054. This Z, this number greater than this number. So it means the Z-test statistic greater than the critical value. So it means we decide reject. Okay, reject the null hypothesis. So this is the decision. And conclusion. I have provided a conclusion. So the conclusion. Let's continue. The scientist carries out the test correctly, but another scientist claims that she has made a type 2 error. Comments on this claim. I have provided my answer. What? Continue to number 7. Ah, already done. Thank you, students.